Okay, so let's talk about what REST actually is. It's a really important architectural style for building web API. Instead of relying on complex protocols like SOAP, REST focuses on how we interact with data online. The key thing to remember is that it's stateless, meaning each request your client makes contains all the information needed for the server to understand and process it. It's also a clear division between the user interface, the client, and the data storage, the server. And crucially, responses are designed to be cache, which can significantly improve performance. Finally, REST promotes a uniform interface using standard HTTP methods like get, post, put, and delete to work with resources identified by URL. Pretty straightforward, right? Okay, let's talk about REST versus SOAP. Both are ways for different computer systems to talk to each other over the internet, but they're built very differently. SOAP is an older protocol and it uses XML. It's like a really detailed instruction manual that you have to follow exactly. It can be quite complex. REST, however, is more of an architectural style. It's based on using standard HTTP methods, things you're already familiar with when browsing the web. It's simpler, more flexible, and generally easier to work with. Think of it as a more streamlined approach. Okay, so let's talk about resources in REST. Basically, a resource is anything you can work with, like a user profile, a product on a website, or even an order. It's just something that makes sense to represent and interact with digitally. Think of it as the core thing your API deals with. Each resource has its own unique address, kind of like a street name, and we called that address in the URL, for example, /users/123 for a specific user. It's all about making things clear and easy to find. Okay, let's talk about the core verbs of REST API, the HTTP methods. You'll encounter get, post, put, patch, and delete quite a bit. Get is all about reading data. It retrieves an existing resource. Parse creates something new, like a blog post or user account. Put is used to replace an entire resource with new information. Think updating a complete profile. Patch makes targeted changes, modifying only specific parts of a resource. And finally, delete removes a resource entirely. Knowing which method to use for each action is fundamental to building well-designed RESTful API. Okay, let's talk about how we represent relationships between resources in RESTful API. It's important to think beyond just individual endpoints. It's about creating clear connections. One common way is through the URL itself, embedding the relationship directly within the path like /post/postid/comments. Another powerful technique is heiters, where links are included in the responses, guiding clients to related resources automatically. Finally, you can also use separate collections for related data, such as /users/user-id/orders. Each approach has its pros and cons, so it's about choosing what best fits your specific needs and the overall API design. Okay, let's talk about status codes. They're like little messages your API sends back to a client after each request. Think of them as the language of your API. They tell the client whether things went smoothly or if there was an issue. For example, a 200 OK means everything's great. A 404 not found tells the client that the item they were looking for doesn't exist on the server, and so on. Using these codes consistently is key to building reliable and user-friendly applications. Okay, let's talk about idempotency. It's a really important idea when designing REST API. Basically, it means that if you call an API operation multiple times, the final outcome is always the same as if you had called it just once. Imagine ordering pizza. You wouldn't want 2 pizzas to show up every time you order. Get and head requests are always idempotent. They're just retrieving information. Put can be idempotent if your code handles duplicates correctly, and delete can be too, but it requires careful design. Post, on the other hand, is never idempotent because it creates new resources. Okay, let's talk about versioning RESTful API. It's surprisingly important. You need a strategy to manage changes without breaking existing clients. There are a few common approaches. One is using the URI itself, like /phone/users or /v2/users. It's straightforward, but can lead to really long URL. Another option is header versioning, where you specify the version in the accept header. This keeps your URL cleaner, but requires clients to understand and use headers. You could also use query parameters like /users version equals to, but that's generally not recommended because it clutters the URL and can be easily missed. When choosing a method, consider some for major changes, minor updates, and patches. This provides clear communication about what's changed. It's really important to prioritize backward compatibility whenever you can, and have a plan for deprecating older versions when necessary. Okay, let's talk about how to handle mistakes when building REST API. It's super important that your API doesn't just silently fail, it needs to tell the client what went wrong. We use standard HTTP status codes like 400 or 404 to indicate a problem, but those codes alone aren't enough. You should always include detailed error messages in the response body, usually as a JSON object. This helps the client to understand exactly why something failed and what they can do about it. Think of providing specific field names when there's an input validation issue. That's incredibly helpful. And remember to keep your error format consistent across all your API endpoints for easier handling on the client side. Let's talk about HETO, as it's a really important concept in building good RESTful API. Think of it as giving your clients a roadmap, rather than just handing them the data. It involves exposing links within your responses that tell the client exactly what they can do next, like edit this product or go to the next page. HETO helps decouple the client from needing to know every single step. The server controls the flow, making your API much more flexible and easier to maintain. It's a core principle of REST, but not strictly required, focusing on hypermedia links and how they represent relationships between resources. Okay, let's talk about put and patch. Both are used to update resources in a REST API, but they're quite different. Think of put as replace the whole thing. It sends all the data for the resource and completely overrides what's already there. It's like saying, here's the new version of this file, discard the old one. Then there's patch, which is more targeted. It only updates specific parts of the resource. So, if you just want to change a single field, patch is usually the better choice because it's more efficient and less risky. Let's break down an example of each. Put replaces the entire resource with all new information, while patch only modifies specific fields within that existing resource. Okay, let's talk about securing your REST API, specifically how we handle who's trying to access them and what they're allowed to do. Think of it like a nightclub. Authentication is checking if you have a valid ticket proving who you are, while authorization is determining whether you're on the VIP list and can get into a certain area, maybe the dance floor or just the bar. We've covered some basics like basic authentication, API keys, and OAuth 2.0 for identity verification. Then we looked at how to control access rights using roles like admin vs regular user, attributes, and policies, which can get pretty complex depending on your needs. Remember, security is layered. Always use HTTPS and validate everything. Okay, let's talk about pagination, a really important part of designing good REST API. When you're dealing with lots and lots of data, you don't want to send the entire dataset at once, right? That would be slow and overwhelming for the client. So how do we handle it? There are a few common ways. First up is offset-based pagination. Basically, the client tells the server, give me item number X, and the server delivers from that point forward. Then there's limit-based pagination, where the client asks for a fixed number of items per page, like 10 or 20. Another technique is cursor-based pagination. It uses something like an ID to track where you left off on the previous page. This tends to be more efficient if your clients are frequently requesting new pages. And sometimes people use a hybrid approach. Finally, remember to leverage HTTP headers like link and total items. These give the client all the information they need to navigate effectively. And don't forget about optimizing those database queries. Okay, let's talk about statelessness. It's a really important concept in RESTful API. Basically, every time you make a request to the server, you have to include *, the information needed to satisfy that specific request. The server doesn't remember anything from previous interactions. It's like ordering at a fast food restaurant. You give them your order, and they start working on it without needing to recall what you ordered last time. This design makes the system much easier to scale, more reliable, because if one part of the server goes down, requests just restart, and it's also simpler overall. Okay, let's talk about content negotiation in RESTful API. It's all about letting the client decide what kind of data they want back from your API. Imagine ordering food. You don't just say food, you specify what type of food you crave. Clients use an accept header to tell the server exactly which formats they can handle, like JSON or XML. The server then checks if it can provide that format and returns a response with a content type header matching the client's request. It's super important because it makes your API flexible for different clients and also helps optimize bandwidth usage by only sending data in the requested format. Okay, let's talk about securing your REST API. This is a really important area in interviews. They want to see you've thought about how to protect the data and functionality. The core strategies are authentication, making sure we know who is requesting something, authorization, checking if that user has permission to do what they're asking for, then carefully validating any input to prevent problems like SQL injection or cross-site scripting attacks. Rate limiting helps stop attackers from overwhelming your server with requests, and always using HTTPS is non-negotiable. Beyond those basics, demonstrating awareness of tools like WAF and CSP shows a deeper understanding of security best practices. Okay, let's talk about URI and URL. They're closely related but have distinct roles in API design. A URL is essentially an address. It tells your browser exactly where to find a specific resource on the internet. Think of it like a street address for something online. It includes things like the protocol like HTTP or HTTPS, the domain name, and the path to the resource. A URI, on the other hand, is a broader concept that * identifies * a resource. It's more about what the resource * is *. A URL is just one way to represent a URI. You could use an ID number, for example. It's helpful to think of it this way: every URL is a URI, but not every URI is a URL. Okay, let's talk about nested resources in REST API. They're great when you have data that naturally has a hierarchical structure like an organization chart or a blog with posts. You can use them to represent relationships clearly, and it often avoids creating huge, flat resources which are harder to work with. However, be careful not to overnest. Too many levels can make your URL really long and confusing. Think about whether embedding data within other entities or using multiple relationship endpoints might actually be a better fit for your specific needs. Okay, let's talk about how to document your REST API effectively. Think of documentation as the user manual. It needs to be clear and concise so developers can quickly understand what your API offers. You'll want to clearly state the URL for each endpoint, which HTTP method is expected, GET, POST, etc., and detail all the parameters you might need. It's really helpful to use JSON schema when defining your request and response body formats. That adds a great level of standardization. Don't forget to specify what to expect in terms of error codes or response types. Finally, providing example requests and responses can be incredibly valuable. Now, there are lots of tools out there to help you with this. Swagger and OpenAPI are industry standards. Postman is fantastic for testing and documenting, and README.io is a dedicated platform for API documentation. API Blueprint is another option that uses Markdown. Okay, let's talk about CORS. Basically, it's a security feature that prevents JavaScript running in your browser from making requests to other websites without permission. Imagine you have an API. Your server is like a secure building, and browsers are delivery trucks trying to get packages inside. Without CORS, the truck wouldn't be allowed to just drop off anything. CORS protects users by preventing malicious scripts from accessing sensitive data on your backend. It's all about controlled access, ensuring only authorized origins can interact with your API. Let's talk about rate limiting, a really important concept for building resilient API. Essentially, is like a traffic cop for your API, controlling how many requests a user can make within a certain period. Why do we need this? Well, it protects against attackers trying to overwhelm your service with bogus requests and helps ensure that everyone gets a fair chance to use your resources without slowing things down for others. There are several ways to implement rate limiting, like the token bucket or leaky bucket methods, each with its own strengths. And don't forget about client-side versus server-side implementation. While clients can do some control, server-side is usually more reliable. Okay, so when you're talking about REST versus GraphQL in an interview, it's important to understand the trade-offs. REST is super familiar, most developers know how it works. It's great for simple API where you have a clear set of resources and relationships. A big advantage is that it's easy to cache data using standard HTTP caching techniques, which can really speed things up. Plus, because it's stateless, your servers are less complex and more scalable. However, REST can sometimes lead to issues with overfetching, meaning you might be getting way more information than you actually need in a single response, or underfetching, where you have to make multiple requests to get all the data you require. And managing API versions can also become a bit of a headache. Okay, let's talk about caching in REST API. It's a really important part of building efficient and scalable systems. Think about how many requests your API gets. Caching helps dramatically reduce the load on your servers. We can do this at the client side with things like setting cache control headers to tell browsers how long to store data, or at the server side using tools like Redis or Memcache to quickly serve frequently requested information. CDN are also a great option for distributing content closer to users. And of course, you need a strategy to make sure your cache stays up to date. That's where things like TTL and invalidation strategies come in. When answering questions about this topic, consider asking which data should we prioritize caching and how do we balance performance with keeping the data fresh. These are common interview points. Okay, let's talk about how we manage those operations that take a while, the ones that aren't instantly resolved by your API. The key here is decoupling the initial request from the actual work. We want our API to respond quickly, so we typically use asynchronous processing, which means sending the task off to a message queue like RabbitMQ or Kafka. This way, the client gets a 202 accepted response. Basically, I put this in the queue, I'll get back to you. You can also set up webhooks so that when the operation finishes, your client gets notified directly. And if webhooks aren't an option, we might use polling, where the client periodically checks on the status of their request, but it's important to do this smartly with reasonable retry intervals and good error handling. Finally, providing regular status updates via dedicated endpoint is always a great idea. Okay, let's talk about how API actually talk to each other. We often hear the terms synchronous and asynchronous, and it's important to understand what those mean. With a synchronous API, it's like making a phone call. You dial, you wait for someone to answer, they respond, and then you hang up. You have to wait for that entire interaction to finish before moving on with anything else. An asynchronous API is more like sending an email. You send the message and immediately do something else. You don't just sit there waiting for a reply. The API returns what it needs without holding your request open. This makes things much more efficient, especially when dealing with lots of users or complex operations. Thinking about blocking versus non-blocking behavior is key. Your synchronous API block the execution flow until they receive a response, while asynchronous ones allow other tasks to run concurrently. Okay, let's talk about naming conventions for your RESTful endpoints. It's surprisingly important. Think of it like this. Clear names make your API much easier for developers and you to understand and work with. A really good rule is to generally use plural nouns for collections, so /users instead of /user. Then combine verbs with nouns to describe what's happening, like /users/create. We usually go with lower camel case for the names themselves, something like create user. And it's a good idea to avoid trailing slashes. Ultimately, your endpoint name should make sense within the context of your application's domain model. Okay, let's talk about how to handle errors when a client sends invalid data to your RESTful API. It's crucial that you don't just say invalid request. Instead, provide clear and specific feedback. The standard HTTP 400 bad request status code is your friend here. But the real key is in crafting a detailed error response board, usually in JSON format. This should tell the client exactly which fields were problematic, what the specific errors are, and maybe even suggest how to fix them. For example, if they entered an invalid username, you'd let them know it needs to be between 3 and 20 characters. Consistent error codes make it easier for clients to build robust handling logic. Okay, let's talk about middleware. In a RESTful API, it's like an extra layer that sits between the client and your main code. Think of it as a helper that does things before or after your main logic processes a request. It can handle lots of different tasks, checking if someone is authorized to access a resource, logging every request for debugging, or even making sure the data coming in is actually valid. Using middleware makes your API more organized and easier to update later on. Okay, let's talk about 401 and 403. These are two common HTTP status codes you'll see when working with API. Think of a 401 as the server saying, "Hey, I know who you are, but you need to prove it, show me your credentials." It's an authentication problem. On the other hand, a 403 is like the server saying, "I know who you are, and you're logged in, but you just aren't allowed to do this. It's all about permissions. Maybe you don't have the right access levels." Okay, let's tackle this question. Can a RESTful API actually have state? The core idea behind REST is that each request needs to stand alone. Think of it like ordering food at a restaurant. You don't need the waiter to remember your previous orders. Every time you place an order, make a request, you provide all the information needed and the server fulfills it without remembering anything from before. This stateless approach is super important for scalability. It means we can easily add more servers as demand grows. While REST primarily emphasizes statelessness, there are ways to mimic state using things like tokens for authentication or clever caching. It's all about designing your API carefully. Okay, let's talk about API testing. A key part of the interview is understanding what tools you're comfortable using. Postman and Insomnia are super popular for manually crafting requests and building collections. They are really user-friendly. Curl is your go-to command line tool if you need to script things or integrate with automation processes, especially in CI/CD. Swagger UI and the Open API specification are vital for actually using API that have been designed according to best practices. And don't forget about performance testing. Tools like JMeter or Gatling help you simulate lots of users hitting your API at once, so you can make sure it's fast and reliable under pressure. Sharing a mix of these tools demonstrates you've thought about the whole process. Okay, let's talk about designing an API for a social media app. It's a really common interview question. The first thing we need to consider is the core functionality. How will users manage their accounts? We'll want to handle user authentication and profile management. Then we move on to post, creating them, retrieving them, and displaying a feed of content. Following and followers are also critical for social networks. And of course, likes and comments provide ways for users to engage with each other's content. To make this work well, we need to stick to RESTful principles, using standard HTTP methods like get, post, put, and delete, and structuring our URL logically. Think about things like user ID and post ID. It's all about creating a clear and predictable API. Okay, let's discuss how we handle deleting data in API. There are two main strategies: soft deletes and hard deletes. With a soft delete, we don't actually erase the record from the database. Instead, we mark it as deleted, often by adding a timestamp to a column like deleted it. The data still exists, allowing you to potentially restore it later if needed. This is great for things like archiving or auditing. On the other hand, a hard delete permanently removes the record from the database. It's gone. This frees up space and simplifies queries, but you lose the ability to recover the deleted data. Which one you choose depends on your specific needs. You need a way to potentially bring data back, or is it okay to just get rid of it completely? Okay, so let's talk about API gateways. Imagine you've built a bunch of different microservices, each one does something specific for your application. Now, all these services need to be accessed by various clients. An API gateway is like the concierge at that building. It takes all incoming requests and figures out where they actually need to go. It handles things like security, making sure only authorized users can access certain parts of your system, and it also helps prevent any one service from getting overwhelmed with too many requests by using rate limiting. Plus, the gateway provides a central place to monitor how all those API are being used. It's a huge simplification for developers and improves overall API management. Okay, let's talk about keeping your public API safe from bad actors. It's really important to think about how attackers might try to abuse them. One key thing is rate limiting, basically telling users how many requests they can make in a certain time period. That prevents things like denial of service attacks. Then always validate and sanitize all the data you receive from clients. This helps protect against injection problems. Strong authentication, like using OAuth and proper authorization, making sure people only get access to what they're supposed to, are vital. A web application firewall can act as a gatekeeper, stopping malicious traffic before it reaches your server, and captchas can help stop bots. Finally, consistent monitoring and logging will allow you to spot suspicious activity quickly. Okay, let's dive into hypermedia controls. They're a really important part of making your REST API truly RESTful. Basically, instead of clients having to guess what to do after receiving data, the server provides instructions directly within the response. Imagine a URL with built-in actions. The server embeds links that tell the client exactly where to go next, whether it's to edit a resource, delete it, or view related information, all without the client needing to hard-code specific URL. Okay, let's talk about API contracts. They're super important in RESTful design. Basically, a contract is an agreement between your client, like a web app, and the server that's providing the data. It spells out exactly how you'll communicate, what kinds of requests you'll make, like getting information or creating something new. It also defines the format for exchanging data, usually JSON, and tells you what to expect back in terms of status codes, which let you know if everything went smoothly. A good contract makes sure everyone is on the same page, so there's no confusion when integrating different systems. Okay, so let's talk about query parameters versus path variables in API design. Path variables are really key to identifying a specific resource, like a user ID or a product code. They are always part of the URL and help build that structure. Think of them as defining what asterisk you're looking for. On the other hand, query parameters add extra information or filter things like sorting order or page numbers. They modify how you view the resource but aren't essential to its identification. We use them when we want to add flexibility and control to our API. Let's break down some key differences in a simple table. Okay, let's talk about OpenAPI, also known as Swagger. It's essentially a blueprint for your RESTful API. It's a standard way to describe how your API works, like a contract between you and anyone using it. OpenAPI defines everything from the URL of your endpoints to what data they expect and return. This is super helpful because it lets us automatically generate documentation, making it really easy for developers to understand how to use your API. It also makes testing simpler and can even help create code samples for different programming languages. Ultimately, OpenAPI promotes a common understanding and reduces the chance of misunderstandings during development. Okay, let's talk about singleton resources in REST. Basically, a singleton resource is one where there's only ever one instance of it throughout your entire API. Imagine it like a global variable for data. Each request to that endpoint always returns the exact same information. A common example would be a user profile. You wouldn't want multiple versions of a single user's details floating around. It's simple, efficient, and keeps things consistent. The key question is really, does this resource naturally represent something that doesn't change over time for a specific entity? Okay, let's talk about localization in RESTful API. It's really important if you want to reach a global audience. Think of it as more than just translating words. It's about adapting a whole user experience for different cultures and languages. You'll need a good system for managing all your translations centrally. When dealing with ID, be mindful don't use hierarchical ID that could cause conflicts across languages. Date, time, number formats, currency, units of measurement, these all have to be tailored to the specific locale. There are a few ways to handle localization in your API. One common approach is using SRT subresource delivery, which means adding a language query parameter to your URL like /products lang equals fr. Or you could use the accept language or even xlocale headers. Let's talk about metadata in API. It's not just the data you get back, it's about the data. Think of it as extra information that helps clients understand exactly what they're dealing with. We're talking about things like describing how your JSON is structured, giving HTTP status codes and content type headers so the client knows how to handle the response, and even providing links to related resources for easy navigation. Essentially, metadata makes your API much more robust and easier to use. Okay, let's talk about logging in RESTful API. It's a surprisingly important area often overlooked. The key is to go beyond simple text logs and really embrace structured logging using JSON format. This makes analyzing your log data much easier. Don't forget context. Include things like request ID, user identifiers if you have authentication, timestamps, IP addresses, and any other details that help you understand what's happening in the API. Then use different logging levels: debug for development, info for general operation, warning for potential issues, error for actual problems, and critical for severe errors. And absolutely log both the incoming requests and the outgoing responses, again, being careful to sanitize sensitive data like passwords. Finally, a well-structured error log with detailed messages and stack traces if possible is invaluable for troubleshooting. Okay, let's talk about handling file uploads in your REST API. It's a really important consideration for many applications. First off, you'll almost always want to use the multipart/form data content type. That's the standard way to send files through HTTP requests. Usually, you'll be using a POST request to handle these uploads. Think about setting reasonable file size limits both on the client and server sides, and definitely validate those files on the back end to prevent any unexpected or malicious content. When an upload fails, it's crucial to give clear and helpful error messages back to the user. Finally, when implementing this side of your API, consider streaming large files into memory to avoid overloading your server, and decide where you'll store those uploaded files, whether that's locally or in a cloud storage service. Okay, let's talk about public versus private API. A public API is like an open door. Anyone can walk in and use it to build something awesome with your data and services. It's designed for external developers. On the other hand, a private API is more of a behind-the-scenes system, used only within your own company. Think of how different departments communicate internally. They have stricter security measures and aren't intended for public use. We've summarized the key differences in this table: accessibility, authentication methods, and even documentation levels can vary significantly between the two. Okay, let's talk about service discovery and microservices. Think about it, you're building an application out of lots of little independent services, and each one might be moving around quite a bit. That means their addresses can change constantly. Service discovery is essentially the process of automatically figuring out where these other services are located, so your API doesn't have to constantly hunt for them. It avoids hard-coding IP and ports, making everything much more resilient and easier to manage during deployments, which is super important in a dynamic microservices environment. Okay, let's talk about keeping your API users happy when you make updates. Backward compatibility is key. The simplest approach is often versioning, add a /phone/ or /v2/ to your URL. But it's more than that. You need a clear deprecation strategy, giving clients plenty of time to adapt. And if changes require data format shifts, think about offering conversion tools. Okay, let's talk about partial resource updates, a really common question you'll get in a REST API interview. When a client isn't looking to replace an entire resource, they just want to tweak some parts of it. The best way to handle this is usually by using the patch method. Patch is designed specifically for these kinds of updates and is much more efficient than put because it doesn't require sending the whole thing again. It's also important that your patch requests are idempotent, meaning that repeatedly calling them will always result in the same outcome, even if there's a network hiccup. If your API changes significantly over time, don't forget about versioning to ensure you continue supporting older clients. Finally, clear documentation is crucial. Clearly stating which fields can be modified via patch and any associated rules makes your API much easier for developers to use. Thank you for watching.